Hey everybody, how you doing? Mr. Elliott here. We are doing our normal distribution lesson today. Let's take a look at it. Um, now, this is the problem I'm about to do. People find these problems to be pretty simple when they understand what's going on, but if they don't understand what's going on, these examples can be really confusing. So what I suggest is that if you're able to follow this lesson, great. But if you're finding in any way confused, then just stop, get all the notes on your paper tonight beforehand, and then watch it again after I've introduced the topic tomorrow. Probably make a lot more sense then. Anyway, in this story problem, we're talking about a watermelon, yay, and it reminds me summer's coming, and says that the average watermelon has 80 seeds with a standard deviation of 5 seeds. Now, the key word here is normally distributed. And when you see normally distributed, what should pop into your head is 68, 95, 99.7, 68, 95, 99.7, 68, 95, 99.7. Because what it's telling you is this. And this is what I'm going to be talking about in class on Thursday. The mean, the average, is 80 seeds, so that goes in the middle. And because it's normally distributed, we have a standard looking bell curve here. And in the middle of my bell curve, not a very good bell curve here, the middle's not right about here. Standard deviation of 5 seeds. That means that one standard deviation away is going to be 85 seeds in the positive and in the negative direction. So 75 seeds. If I stretch another standard deviation in the positive and negative direction, the second one would be 90, and over here would be 70. And we're talking watermelon seeds here. A third standard deviation is 95 in the positive direction and 65 in the negative direction. And what the 68 means is that 68% of the data falls within one standard deviation. And the 68% gets split up amongst these two. So you have a 34% here and a 34% there. 95% of the data fits within 2 standard deviations. And if you go 95 minus 68, you get a 27, which means 27% of the data is unaccounted for, which goes here and here. So that's half of 27 is 13. So 13.5% of the data and 13.5% of the data. And then within 3 standard deviations is 99.7% of the data. And let's see, if so far we've accounted for 95, 99.7 minus 95 is 4.7. So 4.7% of the data gets split up amongst these two, which would be 2.35% and 2.35%. So 99.7% of the data falls within 3 standard deviations, which means the rest of it, which is 0.3%, you divide that out amongst the two. 0.15% is way over here, and 0.15% is over here. We have just set up the problem. Now we can actually solve them. When you're doing this, your homework tonight, do this on every single problem. Once these numbers never change, these numbers always stay the same, but these numbers change. But if every single problem you're writing 34, 34, 13.5, 13.5, 2.35, 2.35, 0.15, 0.15, you'll remember those numbers on test day and it'll make your life easier. All right, here we go. Part A. What percent of watermelons have between 75 and 90 seeds? So you find 75, you find 90, and it essentially means that if you shaded between 75 to 90, how much is shaded? Well, it's 34%, 34%, and 13.5%. So 35, let's see, it says what percent, so I'll use percents. So 34 plus 34 plus 13.5, and let's see, that's 68, which means, which would be 81.5. So 81.5% of watermelons have between 75 and 90. Part B. More than 85 seeds. Well, if you're going to go more than 85 seeds, that could be anything over here. More than 85. That's these three sections. So it's 13.5 plus 2.35 plus 0.15. Let's see. 2.35 plus 0.15, that adds up to 2.5. 2.5 plus 13.5, that works out to be 16%. Yes, yes it does. And then the last one, part C. What percent of watermelons have less than 70? Well, you locate 70 here, and here's 70. And then anything less than 70 seeds. So that would be 2.35 plus 0.15, which gives me 2.5%. All right, and that's it. That's how all of these problems work out. You get the mean and the standard deviation, you build the graph. And this graph is always the same. This top part's always the same, only the bottom changes because you have a different mean and a different standard deviation. But because it's normally distributed, these numbers up top will always remain the same. Then, as you work the questions, you just think, well, if I was shaded between 75 and 90, what do those three sections add up to? More than 85, what do the sections above 85 add up to? Less than 70, what do the numbers less than 70 add up to? These problems always work out the same, and if you're able to do this one example perfectly with complete comprehension, you'll probably be able to do the rest of the homework as well too. That's all I have for you today, everybody. Pretty darn quick lesson. But like I said, if you didn't understand what I did here, hopefully tomorrow's introduction will kind of fill that in for you. Then you can pull off those problems afterwards. Anyway, have yourselves a great day. I'll talk to you later. Bye-bye.